Okay, in this lesson, we're going to finish up working on our systems of equation word problems. So we're going to have 3 different types that we're going to work on tonight. So this video is a little bit longer. If you need to pause and take a break in the middle of it, please make sure you do that. Okay, so the first type we're going to talk about are coin problems. Now, just like the last time, we're going to underline and make sure that we mark up our word problems so we know what we have. So we have Rococo has 28 coins, all of which are either nickels or dimes. The coins are worth a total of $2.60. Find how many dimes and how many nickels he has. So I already set up the chart for us. And every time you set this chart up, this is what I want it to look like. I want you to put the types of coins or dollar bill or bills that you have, and then a total. And then along the side, I want you to always have number of coins and then the dollar amount that you would have. So make sure that when you set up your charts, and you'll see all of mine are set up this way. So for totals, total number of coins was 28. We got that right out of the reading, 28. Total dollar amount was $2.60. We don't know how many dimes we have, and we don't know how many nickels we have. But we do know that dimes are worth 10 cents and nickels are worth 5 cents. I also know that we don't really like working with decimals. So as long as we get rid of all 3 of the decimals, then we can keep working on it. So if we get rid of the decimal, we technically don't need that 0 either. So now I have 2 equations. I have D plus N equals 28, and I have 10D plus 5N equals 260. Now this isn't solved for one of the letters, so we know that this problem is better suited for elimination. It wants to know how many dimes and nickels he has. So you could take the top times a -10 if you want to cancel the dimes. You could take the top times a -5 if you want to cancel the nickels. I am going to go with a -5. So we will make sure you are distributing that to all of your pieces inside the parentheses. So we have -5D minus 5N, and -5 times 28 is -140. And then we add down. 10D minus 5D is 5D. Those cancel. 260 minus 140 is 120. Now if we divide both sides by 5, we get the dimes to be 24. Now we need to make sure that we go back and we substitute this in. Let's not use red since we already have that color. We're going to substitute dimes in right here. Now use an original formula. Don't use this one because that's the one that we changed. So use an original formula. So I can say dimes are 24 plus nickels we don't know equals 28. Subtract 24 from both sides. So nickels would be 4. So those aren't too bad. Let's look at another example. This one's going to be slightly different than the one before. Rosa has $3.10 in nickels and dimes. So we have nickels, we have dimes already in our chart. She has 10 less nickels than dimes. I don't really know how to put that in my total, in my column, but I do know that I can start with the total dollar amount. So she has $3.10, and she has 10 cents for the dimes, 5 cents for the nickels, And we talked about before, if we remove all of the decimal places, then it's okay. So she has 10 less nickels than dimes. She has 10 fewer nickels than dimes. So our nickels are going to be equal to the amount of dimes we have minus 10. So I'm actually not going to be able to use the chart to get that part of it filled out. This would require just a little bit of thought. What's happening with the nickels? What's happening with the dimes? But we can go ahead and write this one down. 10D plus 5N equals 310. This looks like to me, since it's already solved for N, this is a good substitution problem. We can take that N equals information, put it into the second equation where the N is. So 10D plus 5 parentheses, 5 times D minus 10 equals 310. And I'm going to make sure that D looks a little bit more like a D and a little less like a 0. There we go. Well, I don't know that that improved. Okay, so doing our steps to solve equations, we're going to distribute. So 10D plus 5D minus 50 equals 310. Add like terms. So 15D, oh goodness, I don't know what's happening with my pen. 15D minus 50 equals 310. Add 50 to both sides, so we're going to have to come up here. So 15D equals 360. And then we want to divide both sides by 15. So dimes, we have 24. Now we need to put that back into our equation. We just found out what the dimes were. So nickels would be dimes minus 10. 10 less nickels than dimes. So the nickels would be 14. Okay, so this next example, instead of coins, this time we have bills. So a bank teller has a total of 124 bills. So if we look here, we have 5s and 10s. So we have 5s, we have 10s. This time we have the number of bills and the dollar amount. So before we had the number of coins and the dollar amount. Now we have the number of bills and the dollar amount. So we have a total number of bills of 124. The total value is $840. So we have 5s and we have 10s. A $5 bill is worth $5 and a $10 bill is worth $10. So we make sure that we put the amount in there. So let's write our equations to the side. We have F plus T equals 124. We have 5, whoops, we have a typo here. Let me fix that. That should have been 5F, so make sure you fix that on your paper too. So 5 times each 5 plus 10 times each 10 equals 840. Since nothing is solved, we could use elimination. It's not the only way to do it. If you wanted to solve one of them for F or T, you could do that. We want to find how many of each kind. So it doesn't matter if we take the first one times the -5 to cancel out the F's, or if we take the first one times the -10 to cancel out the T's. I think this time we'll cancel out the first one. So let's take it times the -5. So remember, you're distributing that into everything. So -5F minus 5T, and -5 times 124 is -620. So we add down. 10 minus 5 is 5T. 640 minus 820 is 220. Is that right? Yep. Divide by 5. So the number of $10 bills that we have is 44. And then we want to take that and we want to put that back up here into our equation. I think I selected the same color I had before. We want to put that right there. So 5s plus 10s, which are 44, equals 124. If you subtract 44 from both sides, 5s equal 80. So we should have 80 $5 bills and 44 $10 bills. Okay, so I'm going to go ahead. If you haven't paused already and tried one, I want you to go ahead and pause, and I want you to try this last one on your own, and then when you're ready, hit play and see if you get it right. Okay, Vinny has $3.60 in coins, so that is the total amount. He has quarters and dimes. There are 27 coins, so that's the total number of coins that we have. So he has quarters and dimes, and we know quarters are worth 25 cents. We know dimes are worth 10 cents, and we know that we can get rid of all 3 decimal points, and that makes it okay. Let me blow that up a little bit and get rid of that decimal point too. Well, that's what happens. Okay, so let's write our 2 equations that we have. We have quarters plus dimes equals 27, and we have 25Q plus 10D equals 360. I am going to take the top times a negative 25 and get rid of the quarters. You could have also taken it times a negative 10 to cancel out the dimes. Remember to distribute that to all 3 pieces. So negative 25Q minus 25D, and negative 25 times positive 27 is negative 675. Add down, so that becomes 0. That becomes, negative 15D, and 360 minus 675 is a negative 315. Divide both sides by negative 15. That means we have 21 dimes. Then we want to take that information and we want to substitute it right here where the dimes are. So quarters plus 21 equals 27. My pen's having issues tonight. 27. Subtract 21 from both sides. So for quarters, we have 6. Okay, hopefully you got that right. Now we're going to move on to population problems. So population problems don't have a table because we just need to write 2 equations, and then we'll talk about how to solve them once we write them. Okay, so Central High School is increasing in enrollment by 25 students each year. So we know that anytime we have each or per, that's usually our slope. That's the one that goes with the x, or whatever variable we're using for x. So then we have Park Hill is decreasing by 12 students each year. Park Hill has 2,956 students. Central has 1,989 students. So let's stop before we look at the question that's being asked, and let's see if we can write 2 equations. So Central High School's enrollment, we're going to use E for enrollment. Their enrollment is increasing, so it's going up 25 students each year. So I'm going to use Y for year. And right now, Central High School has 1,989 students. So Park Hill is decreasing by 12 students each year. And right now, Park Hill has 2,956 students. So now we have two equations. The question is asking how many years will it take until they have the same enrollment. This is asking when are they equal? That's what that's asking. When are they equal? So what we want to do is we want to take these equations and we want to make them equal to each other. Or if you remember this type of problem from from a couple lessons ago when we learned elimination and substitution, we said that we can take that second e and we can substitute it in for the first e. So we would have negative 12y plus 2,956 equals 25y plus 1,989. Okay, so they're equal to each other now. We've made them equal to each other. So now it's just a matter of solving. So we usually do letters to the left. So I'll subtract 25y from both sides. That gives me a negative 37y plus 2,956 equals 1,989. Then we subtract 2,956 because we want to do numbers to the right. So we get negative 37y equals negative 967. Divide both sides by negative 37. And y equals 26.13. Now I'm going to go ahead and put a box around that, but the question asked, how many years will it take until they have the same enrollment? It's going to be between 26 and 27 years until they have the same enrollment. Okay, so let's look at another one. It's kind of a similar type of problem that we can have. In a recent poll of 30,000 voters, Donald Trump was leading with 9,500 votes, and Carly Fiorina had 6,744 votes. After the debate, Trump was losing 12 votes each day. So there's a slope word. Fiorina was gaining 17 votes each day. There's another slope word. So we're going to pause. Let's write our two equations. So for Trump, his votes equal. He started with 9,500, but he was losing 12 each day. The votes for Fiorina was 6,744, and she was gaining 17 votes each day. So there's our two equations. Question is, after how many days will they have the same amount? So remember, same means equal. So we're going to do the exact same process that we did the last time. We're going to take the second v, substitute it in for the first v. So we have 6,744 plus 17d equals 9,500 minus 12d. And then we can do letters to the left. So add 12d to both sides. We have 6,744 plus 29d equals 9,500. We're going to subtract 6,744. Don't know what that was. Let's try that again. 6,744 from both sides. So 29d equals 2,756. Then we divide both sides by 29. So the days would be 95.03. So it's going to be between day 95 and 96 when they will have the same amount of votes. Okay, so these last three problems that we have are other type of word problems that require systems of equations. This one is a table. You're going to see that it's kind of similar to the coin problems. The last two don't have a table, so we're going to kind of work through them like we did the population problems. Okay, so tickets to a local school play cost $5 for adults, $2 for children. For the one night show, 285 tickets were sold and $1,065 was collected. Okay, so let's look at our chart. We have adult tickets, we have children's tickets. Then over here we have the amount of tickets, and then we have the dollar amount. So the total number of tickets sold was 285. The total dollar amount was $1,065. We don't know how many adult tickets we sold. We don't know how many children's tickets we sold. But we do know that the adults were $5 and the children were $2. So this looks very, very similar to the type of coin problems we were doing before. So A plus C equals 285. 5A plus 2C equals 1,065. We are going to take everything times, I'm going to do a -2 and cancel out the C's. You could have done -5 and canceled out the A's. That's acceptable also. Distribute. So we have -2A minus 2C equals -2 times 285, so -570. Add down, we get 3A, and 1,065 minus 570 is 495. Divide by 3. A is 165. So we sold 165 adult tickets. Then we can go back and substitute that in right there. So 165 plus C equals 285. We subtract 165 from both sides. So C equals 120 tickets. So they sold 165 adult tickets and 120 children's tickets. All right, so this next one. The sum of two numbers is 75. So we're going to say that the first number is X and the second number is Y, just so we have some variables to use. The sum means add, of two numbers means equals 75. So X plus Y equals 75. The larger number is 3 less than twice the smaller. Now we don't know which one's the larger and which one's the smaller. So we're going to just start with the larger number being X. We're just going to assume the larger number is X. So the larger number, X, is 3 less than. So we'll always put greater than or less than at the end of our equation, because if you're going to have 3 less of something, you have to have that something right here to have 3 less of. So 3 less than twice the smaller. Okay, now that we have our equations written, it says find the numbers. Find the numbers. So this one's already solved for y, so by substitution, we'll put that in where the x is at. So 2y minus 3 plus y equals 75. Add like terms, 3y minus 3 equals 75. Add 3 to both sides, so 3y equals 78. And I'm going to go ahead and come up here. So 3y equals 78. We're going to divide both sides by 3. Y equals 26. Okay, so if y is 26, here's where I can substitute that y. So x equals 2 times 26 minus 3. Or you could have put it in right here. Let's do that one instead because that one requires a little less math. Let's try that one. I'm going to erase this. So if you need to pause and erase, do that. So let's say x plus 26 equals 75. Then if we subtract 26 from both sides, see that's much fewer steps. If we picked this one and x is 49. Okay, last example. The units of a 2-digit number. So a 2-digit number means it has two numbers in it. So like 25 or 98, so two digits. The units digit, so that's going to be the last number. So like 21, 1 is the units digit. 98, 8 is the units digit. So the units digit is x. The tens digit is y. So the units digit is, we know is means equals, 1 less than 3 times the tens digit. So the units digit is 1 less than 3 times the tens digit. The sum means add, is means equals 11. So x plus y equals 11. So since 1 is already solved for x, we know that we can substitute. So we're going to have 3y, my pen's getting tired too, 3y minus 1 plus y equals 11. Add your like terms. 4y minus 1 equals 11. Add 1 to both sides. 4y equals 12. Divide both sides by 4. Y is 3. So if our y is our tens digit, so that's 3. We'll put that there. Now we can take that, we can either put it into the first equation or we can put it into the second equation. I'm going to go again with the one that's going to be a little more simple. So x plus 3 equals 11. Subtract 3 from both sides. X is equal to 8. Now the question is asking us, find the original number. So to find the original number, you have your tens digit, you have your units digit, and that's your original number. Okay, don't forget to do the odds. And then when you get to the review problems, make sure you do all of the review problems.